Hello everyone, how are you all? So I am Siddharth Kumar Jha and today I am going to talk about foundation and simple linear regression in machine learning. Okay, so let me tell what is regression. Okay, what do you mean by the regression? Okay, so yeah, correct. Regression is a supervised machine learning technique that is used to predict continuous outcomes based on one or more input variables. Okay. So, for example, suppose predicting house price or salary prediction or your sales forecasting. Okay. So, suppose you are predicting the house price. So, for that, you need some prior knowledge like in your house, like how BHK you are searching for and in which location you are searching for, because based on the size and your location, the cost of the houses varies. Okay, so I hope you get the basic understand like what is regression. So next is like the type of regression. So here is just overview and we will detailed explain in the later. The types of regression is like simple linear regression, multiple linear regression, polynomial regression, and logistic regression, or you can say the classification quick mention. Okay, so like what it fits in machine learning. Okay, so where the regression fits in the machine learning. So regression is fits for the prediction of numbers and classification like prediction of the categories. Okay, so let me go to the notepad for the better understanding and I will write this all point what I have told now for your notes. So let me go to the what it is notepad. Okay, so let me write it down. Regression first. Regression. So let me change the color also. So which color? Pink or white? White is fine. Okay. So regression is supervised machine learning. Supervised supervised machine learning technique that used to predict uh, uh, continuous outcomes continued outcomes based on one or more input variables. Okay, so for example, suppose you are predicting house price, or you can say salary prediction, or sales forecasting. Sales forecasting. Okay, so next we will talk about the types of regression. So the next is like types of regression. So if you talk about the types, so there is like first one, which is simple linear regression. Second one is your multiple linear regression. And the third one is your polynomial regression. Polynomial regression. And the last one is your logistic regression. Okay. So where it fits in the machine learning? So for the predicting the numbers and the classification like prediction of the categories. So now we will talk about the mathematical foundation of machine learning. So let me go to the slides. So mathematical foundation. So first we have to understand the variables. So dependent variable y, which outcome to predict. Okay, and independent variable is which is x, which is predicted feature. Okay, so equation of line, as we know, like b naught plus b1 x plus sigma y, it is nothing but y is equal to your a plus mx plus c. Okay, so the same thing I have written here. So the least square method, so it minimizes the error between predicted and the actual values. So there is two approaches. The first one is analytical approach and iterative approach. Okay, so analytical approach means it is a normal equation and iterative means gradient descent. Okay, so I hope this is clear. So for detailed understanding for this one, I have to go to the notepad. Okay, so just wait a second. Okay, so here we have understand the types. We don't worry, we will do it in detail later on in this video only, or maybe in the next video. So the mathematical foundation. Let me write on the mathematical foundation. Okay, so the first one is your dependent and independent variable. Okay, so first we will talk about the dependent variable. So dependent variable is your y value, okay, and what we want to predict, okay. So it is nothing but what we want to predict. Suppose salary or rent, etc. Okay. So these all are comes in the dependent variable because these all are things like dependent on something which salary is dependent on your like post or your department or your company. Okay, and rent is decided on your location or your size of your house like that. Okay, so these are dependent, and the independent variable. Independent variable is denoted by x, and it means like features that affects y, features that affect y. Okay, so for example, like year of experience. So okay, so example like years of experience. Okay, so I hope this is clear. So now we'll move further for the equation of a straight line. So the equation of a straight line is equal to y is equal to mx plus c. Okay, so here let me go to the next page. We have seen like straight line equation, which is y is equal to mx plus c. So here c is basically your intersect sorry intercept. Okay, values of y when x is equal to 0. Okay, and there is cost function. So cost function is nothing but your mean squared error, or you can say MSC. Okay, so for j m comma c is equal to 1 by n summation of y of I minus mxi plus c ka square. Okay, so I think this is clear. So finding the best fit line. So finding the best fit line. So we are using ordinary least squared, ordinary least square, which is your OLS, which minimize, it helps to minimize minimize errors. Okay, and the second thing is like mention gradient descent. Uh, so we have discussed it in the detail, like when we have read about the machine learning optimization lecture. So if you are not able to recall it, just go to that video. Okay. So the next one is your simple linear regression. Okay. So the next topic is your simple linear regression. So in the simple linear regression, what it is? So regression model with one independent variable. Okay, so this is your x independent variable, as I have told you. X is your independent variable and one dependent variable, which is your y. So steps to build the model is like, let me write down the steps to build the model is your the first, you have to like collect the data, collect the data for examples, years of experience, years of experience, comma, salary. So suppose you want to predict the salary of an person, so you have to need to know like what is the year of experience of that person. Okay. So the next thing, which is like your plot, scatter, scatter plot to visualize relation, to visualize the relation, and the third step, which is your fit regression line using OLS, fit regression line using OLS. Okay, and the next one, your D is evaluate performance, evaluate a performance. Okay, so I hope I'm clear with the steps to build the linear model. So there is some assumption which we have to know. So let's talk about some assumption. So the first assumption is your linearity. Linearity. So linearity is nothing but the relationship between x and y, x and your y in linear. Okay, and the next is like homo sorry, homo. So this is nothing but the constant variable of errors. Sorry, my I think my mic get muted. So this is your homoscedasticity. So this is nothing but your constant variable, constant variance of the error. Okay, variance. It is nothing but variance. Sorry, my mic was muted for 10 to 20 seconds. I don't know how. So sorry for that. So next thing is your independence. Independence. So it is nothing but like error of independent. Okay. And the last one, which is normality. So normality is your error follows normal distribution. So error follows normal distribution. So this is about the assumptions what we have make on the linear regression. So next we will do the hands-on implementation of the salary prediction. Okay, so for that I have to open my Jupyter notebook. So here I am giving you the data because okay, let's see. There we will give the data only. Okay, so I let me open the Jupyter notebook. So here I will go and search for the Jupyter notebook. Just hold a second. It take I think 10 or 20-second time to open. So just wait. It's loading, guys. Just wait. Okay, so it opened. Okay, so now we will create one new folder, a new file basically, which is new notebook. So in this we will import some library. Select. So first we will import some library, and then we are going to train our model. So first, linear model. So first we have to import the pandas. Import pandas as PD. And the next one we will import pandas. We are importing for the understanding the data sets. Okay, and import matplotlib matplotlib dot pyplot as plt. So this we are importing just for the plotting some graphs and all. Okay, and next one is like from scalar dot linear model. We will import linear regression. So just run this. So it take I think 2 or 3 second time. Just wait whether it is running. Yeah, so it imported all the files. Okay, all the library. Okay. So next we will do our sample dataset we will give. Okay, so we will write like data is equal to pd dot data frame pd dot data frame just a second. data frame, and I will give my data. Okay, so I will write like this, and then I will give like year of experience and salary. Okay, so here you can see like I have given the data as a data frame, and I have given the year of experience and along with the salary. Okay, just for the training purpose, so the data is there. So let's run this. Okay, so next, what we will do? So we will do like your just a second. Write it like x is equal to x is equal to data, and what it is, your year of experience. Okay, so years experience. I will copy this and I will paste it here. Years experience, and your y is equal to data, and I will write like salary. Okay, so let me give it to the commas and just run. Okay, so this is nothing but your what it is, independent variable, independent variable, and this is, sorry, this is nothing but your dependent variable. Okay, so I hope this is clear. So next one, we will move like we will train the model. Okay, so for training the model, we will write like model is equal to linear regression, and then I will write like model dot fit in which x comma y. Okay, so here I have trained my model. So next we will check the coefficient. Okay, so here I will write like print. Okay, print slope, which is your m, and from where we will find the slope. So comma, and model dot cof of 0. Okay, so let's see what we are getting the output for this. So yeah, here we have get the slope of the input data. For this data, I have get the slope, and like this only we will like calculate the intercept. Okay, so print intercept, which is nothing but your c. So its value, and from where? So model dot what it is, intercept. Okay, so just run this. So intercept value you will get. Okay, so now we will do the prediction. Okay, so the for the prediction I have to write like y underscore predict is equal to model dot predict, and what I have to predict, the x value I have to predict. Okay, so next we will do the visualization of this. So for the visualization I have to write like scatter plot dot scatter, and in the bracket I will give like my attribute x comma y comma color is equal to like I will give blue, color is equal to blue, and I will give the label is equal to I will give actual data. Okay, actual data. So let's after this we will give like plot plt dot plot, and I will give the value which is x comma y underscore predict comma, and color is equal to red, and we will give the label is equal to what should be the label, regression line. Okay, so now we will x level we will give the year of experience. So plot dot x level, and in this I will give like the years of experience, and plot dot y label I will give like your salary. Okay, so now I will plot like, so plot dot legend and plot dot show. So plot dot show is a function which basically show you the the graph. Okay, plot dot show is a function which is helps to observe the output. Okay, so see here, this is how the regression line. So this is your regression line, red line, and blue line is your actual data. Okay, and year of experience and the salary is there. Okay, so I think from this lecture, you have get the basic understanding of the what is your linear regression and all stuff. So we have learned what is regression is and why it is important, and we have seen the math behind the linear regression, like your equation plus cost function we have seen. So we have built our first regression model in Python using scikit-learn. So we have visualized the regression line with the data set. So here you can visualize it. So in the next lecture, we will understand like multiple linear regression with several features like size, location, etc. for house price, and your polynomial regression for the nonlinear trends. Okay. So this is about the today's video, and if you guys has really liked the video, then just comment your the favorite section and just comment a heart emoji in the comment section so that it gives me motivation for the next lecture. So tab tak ke liye, I hope should I have to wind up this video because it's going too long. So thank you for joining the today's lecture. So see you in the next lecture in the machine learning course. So तब तक के लिए keep learning and keep exploring. Bye bye.